Welcome to another test and teardown video. This one is a timer counter SC3 from Advanced Instruments. As you can see, it contains 4 NIXIE tubes. Yeehaw, NIXIEs! I love them. They're just fantastic. I tried to Google this model a little bit, and of course you can find a lot of other Advanced Instruments timer counters, but the SC3 model is completely unknown to the internet. So if you can find me any information, please tell me. I am not able to find anything at all. So there's a nice table holder here. Let's have a look on the back. So this reveals it is set for 240 volts, 1 amp fuse. Whoa, that's 240 watts. So we also got input, reset, everything here on the back. 100 hertz, is that input or output? And here, again, Advanced Electronics. Now they're called electronics. Maybe this can be used for the Google. I'm going to play with that a little bit. But it looks like the case was welded, hand welded or something. So is this aluminium? So then it is something. Maybe we should just power it up right away and see if it is alive. That's gonna be funny, isn't it? Yeah. As always, I promised power up on video. Mains is applied. Hey, yeah. Oh no. This can't be right. Okay. Ooh. So if it's time. So what the heck? So this is of course not a period timer, it is a frequency counter, I guess. Unless start. Probably I need a pulse. Let's try and get it some input. Good idea. I've been trying everything here, inputting all sorts of frequencies and levels and whatnot, and there's just no way I can make this damn thing count or show any goddamn thing. Ew, how shitty shit is that? But this is of course what happens. So we are forced to open and play with it. So let's try to input 100 hertz, 11 volts peak and square wave. It's just hello whatsoever. Start. This thing is not starting anything. Something is totally broken in this thing. Ew. So that was actually a little bit funny. Those 2 screws and then the whole chassis kind of just slides out in the back. I'm starting to think about maybe I need to short something here to make it work. Start, stop, input. Maybe it's the input on the back here that's like working. But anyways, let's have a little look. ZM 1175. Oh, they're beautiful. So what have we got here? That must be some sort of a, so got some counters, decimal counters. It says advanced SE number 4 decade counter SC3. And there will be some transistors driving the NIXIEs. And I think all that stuff actually works. Right, we got some transformators here as well. 2 of them. Voltages seems to be working. We got stuff going on. And it was able to respond to the reset pulse. So that means the counters are working. What is that? Power supply. Looks a little bit crusty, doesn't it? Ooh, that is a funny thing. Look at the brown wire. Wee. Cool. Quite a lot of different voltages and stuff. And then, here at the bottom is where all the fun begins. So that is a pot. And it is connected here. Shielded cable. I mean, what kind of frequencies is this supposed to be able to count? Somebody did solder a lot around here, I guess. Repairing some stuff. We got some. I mean, is this really connected? I better try and see if we can lift this. Okay, we got some shielded cables here, and they go to the back. I think, how do you select between front and back? I think I'll take an ohm meter and measure if there's a direct connection from the front and the back input. I don't know, I need to figure this out because there's no such thing as information online. Oh, so the PCB is definitely using shield as ground. Yes, definitely. Well, and again, look what I'm doing, poking around with my fingers in NIXIE stuff. Ooh, please don't copy that idea, because those things run off at 200 volts and stuff like that. So you can also see some of the capacitors here. So this is a 6 volt, 500 volt. And how much is this one? 18 volt. How about we start measuring the supply voltages? We need to get this thing running. Can't take that long. So here's the power supply. I did find 2 capacitors that was looking a little bit suspicious. That's a little bit funny one. So I think this is actually the date code 70. So that's 50 years old. And the other one, if you look here, you can see the pukety puke. And that was supposed to, well, it went here, right? So let's look at the other side of the PCB. Look at that. All that is the capacitor puke from that one. So after changing those 2 capacitors, at least I got a nice stable voltage on that one. It was full of ribble and crappity crap, but it didn't really help the main problem. here's my input, and it goes via some transistors and stuff. This is a DC offset, where you dial the DC offset in, and then the output goes to the counter board. This output was absolutely missing no matter what I put in, and no matter what the trigger level was, I didn't get anything out of this pin here that goes to the counter module. But look what I did. Now it's counting. So this is 100 Hertz, and I am in ×1 frequency. This counter is not double buffered, so that means you will see the count up, and then it will show the result, and then it will reset and count up again. So it's actually quite nice. Or you can also say count up and then stop, and then you can read the numbers or whatever you want. So that is pretty cute. Look at that. So there's a problem with the reset. This one fell out, so that's why. Now we're going ×10. Obviously the time is now going to be faster, so this is my of course it's going to be like that. I really think this is a super duper nice counter. So all I have to do now is take out this board and find the problem with this transistor stuff. Probably somebody input a lot too much and then blew up the input transistors here. It's not that easy to access this board. How are we going to service this? What I think I need to do is remove the 4 screws, take out this pot, desolder these 2 wires, and then I can probably bend down the board. So that is what I think I will do. Oh, by the way, the time base for this is mains. So it's actually taking 100 Hertz from mains. We are a double rectifier, so you get 100 Hertz. And this is what it's using as its time base. Just like that. Yeah, mains cycle by cycle. And this is of course also why you see this 102, 100 and you see, it is just not more accurate than that. Fantastic. I love NIXIE counters. It's just so beautiful. So this is the bottom side of the input amplifier board, or the input amplifier parts here to the right, and this is the time base. Obviously it is taking the mains voltage in and it's just counting it on those 3 dual JK flip-flops. And the funny thing about the old circuits, see, they're from 1970, that's actually 3-volt parts. Really special and funny parts, 3-volt counters. And they seem to be working pretty good. So here's the problem. Oopsie doopsie. So here's the signal that is missing. And here's our input signal that goes via those parts to that transistor. So this is something. How is it possible to blow this up? They actually did a lot of protection stuff. We got some protection diodes. We got a very high power series resistor. So I think they could actually handle quite a lot of voltage, right? So I've been poking around with all the components here. I got a little bit of loose connections in the different parts here, and that's actually what's causing the problem. Also I got some loose connection in some. See what's gonna happen now? So this is actually 1 kilohertz, and it's definitely, see, if I touch this switch, but it's not just that one. It's also if I touch some of the components here, it's just all full of loose and funny connections. See, now it measures 1000, and then 300, and then oops, no more. It is just really weird. So how fast can this thing go? In the times 10, this is where I am now. This is actually 99 kilohertz, right? 99.9 kilohertz. And now it of course works. Now I can put this thing back together and say thank you very much for watching. Nixie, Nixie, funny, funny.